Welcome to a new video in my home automation series, and today I want to talk about how you could use Modbus under Node-RED. And the reason I'm making this video because I've been using Modbus for a very long time, and probably you have seen quite a few projects which is using Modbus because I'm talking to my home automation PLC over Modbus, and I think I've been using it wrong. And I had all sorts of issues like connection issues and reconnecting issues, and I thought there is something wrong with the Modbus component within Node-RED. But then it turns out that because I was using it for such a long time, probably from a very early version, I got used to a way of using the Modbus nodes in a specific way, whereas I was pointed out there has been a lot of development made in terms of reliability, fixing connection issues, and they are all related to like a different set of nodes that you should use if you have problems like that. So I thought because it was giving us so many problems in the past, I'm just going to cover it in a video so maybe you can learn how to do it right. Before I start going into it, I just want to show you the Modbus component that I'm using. Actually, if I bring up the palette, then so this is it, Node-RED contrib Modbus, and it has a lot of different stuff in it. And in the early version, I think there was, maybe there was just a Modbus read and a Modbus write, and there was like a queue manager and and of course the connection node. So there has been a lot added here. And because I had this earlier knowledge of how I used to use Modbus, I kept using this Modbus read component. And if you just hover over it, then even the documentation says that this Modbus read is okay to use if you have just a few connections. But then if you have a device where you want to do a lot of different queries, then you should really use the flex getter and the flex write node, because most of the work and enhancements and code stabilization has gone into the flex nodes. And I didn't really know about this, so I was trying to just figure out what is going wrong with my Modbus read, whereas I should have just ditched it and used the flex getter instead. So you can see the flex getter here or the flex write node. So this video is about how you use these two nodes. I'm going to show you two different methods. The first method is you can see here. So this is how I communicate with my PLC, and it has a lot of different inputs because I'm querying coils and registers in different quantities and in different addresses with different intervals. So there is a lot that the Modbus node needs to do to queue those messages and make sure that let's say a new request is not sent before the last one is processed. But then I have another one where I'm communicating with a touch panel, where it's much simpler because I'm just only querying a single range of registers. No, I think I do coils, and maybe I write something. So that's simpler. But even for that, I use the flex nodes. And back in the day when we used the old Modbus read, then you would specify the device that you want to, like the PLC that you want to, that this is the Modbus slave that you want to communicate to, and then you specify what is the Modbus function, and then the address, the quantity, and the pole rate. So with the flex node, it is slightly different because in the flex node, you have to specify this in the message that you send in. So if I look at this one, this is how the input message to the flex node should look like. So it has the FC, so this is the Modbus function, the unit ID, the addresses, and the quantity. So exactly what you would specify on the old node. But here you have to send it in a message. And this is why it is flex, because you don't specify it on the node level, because on the node itself you just only specify the slave that you want to communicate with. All the instructions are coming in from the input in the message. And of course this means that you can just use multiple requests and use a single flex getter node to get this information. So let me just show you the easier example, which is here, not here. which is here. Yeah, so as I said, I have a touch panel and I want to get, I think I just 2 coils, so the first 2 coils. So I need to create a message which has, FC1 because it's coils, the unit ID 1, address 0, and the quantity is 2. So I'm just getting these information, and here the value is irrelevant because I'm getting data. And I want to query this device very frequently, actually 500 milliseconds. So in the inject node, I can only do 1 second. So the information goes in, and basically the second one gets a 500 millisecond delay and it goes in. So this is how I get 2 requests at a second. And this is connected via TCP, so I'm not too worried about bandwidth and whether it will be able to handle this request. And I process the information, and then at some point I also need to write something to it. So again, I'm using a flex write. Again, I just only specify what the client is, the Modbus current is, yes. And I also prepare a message, which is very similar to the getter message. So FC5 is reset a single coil, unit 1, address 1, quantity 1, and the value is because it's a coil, it's a true or false, but if this would be a register, then that would be the number that needs to be written into the register. So that's how you specify a write request. Obviously, the difference between the read and the write request is the Modbus function is different. And that's the easy way. So as long as you have, let's say, I can't really tell whether it's 1 or 2 requests, but as long as you have a simpler query where you are only reading a couple of things from the same device and maybe very occasionally write something to it, then you can just use one flex gather node and then one flex write node, and the Modbus itself is going to take care of it. So that's the simpler approach. But then I thought that if for my main PLC I'm going to use a much complicated approach, and basically I'm going to implement my own queuing, and this is what this function node does. And the idea behind it is that I have a lot of different requests coming in. As you can see, I'm reading registers here. So here I'm reading registers from address 1000, I read 20, and I read another, I think it's 20 from here, from address 1200, and another 20 from address 1300, and I'm also, so these are temperatures, and these are my blind positions, so from register 1500, again 20. And there are some other ways I can also input from other parts of the flow or other flows. So these are all going in, so these are the requests. And this function node is going to queue these messages, and then it's going to send them out, and then based on the Modbus function, I know whether that's a getter or a write request. So it would redirect the message on to either to the getter node or to the flex write node. And then if I write something, I don't really care what comes back from the Modbus. I always, assume that it was successfully updated. So I don't really process the output. But for the getter, I obviously process the output here. And because I'm using this single getter for all these different queries, what I do, probably you have seen it before, that I always specify a certain topic. And then obviously that topic comes through all these nodes. So here I know that the message that I got out of the flex getter, whether that is, this type, that type, or, one of these types here. And then I can send those messages to the right places where it gets processed. So that will take care of the actual processing the data that we read from the device. But then, as you can see on the first port of both the flex getter and the flex write, I also send this to this change node, which just sets the topic to next, and that feeds back to the function node, and basically that is saying to the function node that we got a response from the client, so we can send the next message, and that's the whole queuing mechanism. So it sends one message out, and then once there is any response, then it says, okay, we got a response, so we can send the next one. So that will take care of the queuing, regardless whether it's it's a get or a write request. And also this will make sure that there is no get and write request set at the same time. That's the main idea. And then it does a couple of other things as well. Basically let's say three main things. There is an update inject node, which has a topic of update, and that just does basic housekeeping. So you can see here that it will update a message saying how many seconds ago the last message was sent. Sorry, how many seconds ago the last response was received. If it's a really long time, then there is like an internal status management. So it will say that the device is offline or online, depending on how long that time was. And all this information is sent out on the last node. So you can use it for, put it on the dashboard, or, include it in the messaging or logging or something like that. The other point of this whole queuing mechanism is that, at least in my implementation, whenever I either read something or write something, and if the request it doesn't go through, but then another request comes in, because let's say I want to read something every 10 seconds or 2 seconds, I don't really care what was the previous request, because the last request always overrides the previous one. So I only keep the most recent request for each of the each type of the queries. And this is why the message topic is important, because I have a topic which says, query the temperatures or the blind positions. So if I get a second, query temperature request, I just keep that. I don't need the previous one, because, essentially it's always going to be the same anyway. So this is what I use the topic for, that for each topic, the function node is only going to remember the last setting. And actually, this, oh no, sorry, not star flows. So this function node is really fast, or this device is really fast, so we are not going to really see much, but this is where the queue, that's the queue. So this is where all the messages are stored. And as I said, it's, TCP, so as long as a request comes through, it is sent immediately. So we never see anything actually queuing up here. But if you would see, then that's where you would see the messages. So the queue is never going to be huge. It's always going to be like, in my case, it's like 5 or 6, because I have 5 or 6 different type of queries, and everything, whenever a new one comes in, it would just override the previous one. And then you can always see whenever a read request gets sent through or a write request gets sent through. So you can see that it just gets queued up. And it won't get queued up because the client is faster than how fast the messages are coming in. So that's one thing. So I don't keep history. I just always keep the latest version of the message. And the last functionality here, what you can also see here in the this variable or context value, which is called the last message, is let's say you send out a request, but the client is already offline, then you are never going to get a response saying that I have processed the request. But then when the device comes back online, it won't know anything about the request because it was offline. So what this function also does is that it will remember what the last message was, and if there was no response, let's say in 10 seconds, it's going to send it again. So the last message would just keep trying for every 10 seconds. So again, let's say the client is disconnected or the power is gone. Node-RED would just keep sending the last message for every 10 seconds. And then it's also going to just count how long it was since the last communication. And if it goes beyond, like, let's say 2 minutes, it would just send a message that the device is definitely offline. It's not responding for the last 2 minutes, but it would just keep trying, sending the last message every 10 seconds. And then, once the client is back online, it will, in the next 10 seconds, it would get the last message again, it processes, it responds, then the whole thing with this, with this function node and the loopback is going to start again, and it would just pick up where it left. And it is definitely working because I had a small power outage, I think this week, and I also had some, smaller network issues when I think my ISP was updating the router, and whenever this happens, my internet connection goes away for like 2 minutes, but then it automatically comes back, and the communication started, flowing between Node-RED and the client as well. So this is why I'm saying that this method is definitely working with this very complicated setup. So let me show you how it works, because I have a test flow here. This is almost exactly the same as the one above. This is an earlier version of the code which doesn't have the resend implemented, which is good because I think it would just cause issues here. But if we go into the debugging, so you can see that I also have the every 1 second update here, and that would just keep sending out these messages like let me stop. Let's look at this one. So the seconds since the last update was this, and the last update you have a human readable format and you have a state. So that's 99 is offline and 1 is online. So that's the message that the device is offline now. And here you can also see in the status, and then you can see it's offline, so it is red, and we have 0 messages in the queue. So that's fine. So I just reset this node, and then we can see that we have 0 messages in the queue. So if I send my first request in, then it has been sent out almost immediately. So we didn't see anything here, but you can see that I have also simulated this loopback. So after 5-second delay, we have a loopback. So the counter has reset. And if I send in another request, it gets sent out immediately. And now the delay is working. So, and then, once we have the feedback, then the counter resets. And you can also see that, let me just do this one. Okay, and then now we can see that the request was sent out, and because this was a read request, it comes out of the first port. And if I send out a write request, then it gets sent out on the second port, because as I said, the first one is all the getter request and the second one is all the write requests. And if I want to, and if I restart this, then you would see that, the state is now 1 because the device is online and the last message was 9 seconds ago. So you can use this information to, create your own triggers, either on the state change. And whenever the state changes, there is an extra field which is set to true, which I think it's called state change or something similar. We are going to see in the documentation. And I also want to show you the context. So now if we look at the, it remembers when the last update was received, and then the queue is empty and sent is false, so nothing is sent at the moment because we have received a response for the last message. And if I do, and if I break the connection here, let me just do this. And refresh. So if I send the first request in, the request gets sent out, so there is nothing in the queue, and we have a variable which says that we have a message that has been sent out, but we haven't received the confirmation yet. So if I send in another request, then nothing really happens. It just gets queued because it's waiting for a response. So now we have 1 message in the queue. That's the read test. That's the first one. If I send another one, then now we have 2 messages in the queue. So read test 1, read test 2. If I send the write request, then we have 1 more message. With the topic write. And then if I send the read request again, then we still only have 3 because we already had a read request. And if you can see that, well, it has actually gone to the end of the queue, but I guess you get the idea. And I can also simulate the getting a response by sending this next topic manually. So now the latest one was sent out from a queue, so now we only have 2, and now we have only 1, and now we have 0 because we sent out the last message. So that's how it works. Let me just reconnect this one. So that's the this is how I can simulate you the node. And if you are interested, I'm also going to quickly take you through the code in the function node. So we have a couple of variables in the beginning. I'm going to talk about these in a couple of seconds. These are basically control how the logic works within the flow. And first we are checking if there is a topic, because if there is no topic, you get a message that the topic is missing. As I said, it is important. The topic is important for the rest of the code in the flow. And then we get, the values from the context. If we don't, for example, if the queue is not defined, then we just create an empty queue, an empty array. And then we have this big switch node, which looks at the topic, and then it's going to behave based on, what is in the topic. So if the topic is update, which is that every second update, then, it just calculates how much time has spent from the last update to the current time, and then it generates this human readable format of how many days, hours, minutes, seconds been passed since the last update. And this is where I also implemented the resend logic. So if the resend is enabled, which is up here, it checks whether the time since the last send modulus, the resend interval is 0. So let's say every 10 seconds, and then it's just going to send. It takes the last message from the last message variable, and then it's going to send it out. Yeah, it's here. And this is the piece of code which knows whether it needs to be sent out on the first or the second port, because if the Modbus function is 1, 2, 3, or 4, that is a read request, so it goes out on the first node, and if it's anything else, it goes out on the second, sorry, not node, but port. So that this is the resend logic. And here I'm also doing the status management. So as I said, if the status is not 0, and we just got a message, then it's going to send a message out that the device is now online. So you can see that there is a status change variable set to true. So you can look at that one if you want a specific message. And if the time spent since the last response is greater than an offline threshold, then it's going to be another message which says that the device is not transmitting, and it sets the status to 99. And that comes out of the out on the third port. And the next is only used, well, that's basically, this is the feedback loop. Yeah, I wanted to say that it's only used for testing, but no, actually this is the same message what the feedback loop uses, and it just updates the last update, and then it sends the false to sets the send to false, and then the internal send is set to true because it will get used later. There is also a reset function. So if you want to just delete everything, you can just send in a message with a reset topic, and that's going to reset. And if the topic is anything else, and those are the normal requests that are coming in every, let's say, 10 seconds or 2 seconds, then it just gets added to the queue. Oh, sorry, this is where it looks for any existing messages in the queue, and if anything is found, then it's going to delete it, and then it's just going to add it to the queue. And if we don't have anything, if the send variable is set to false, then it means those would be the cases when the flow just started, and this is the first message which is coming in, so that can be sent immediately. So that's why we are sending the internal send variable to true, that you're going to see later. So if the send variable is true, which means that we just received the next, or this is the first message since the node started, then we can send the message out. So we just pick out the first message from the queue, we remove it from the queue, and then we send it out. And we use the same logic as above. So if the function is 1, 2, 3, 4, then it's a getter. If it's anything else, it's a Modbus flex write message. And that's it. That's pretty much it. It's not that complicated. So if you want to use this flow, then in the video description, you will find a link where you can access this tester flow. And what you would need to do is, well, obviously you find some examples here. So you need to replace these with your get or write functions with the correct timing and everything. And in the Modbus queue, within the function node, you have these variables right on the top of the flow that you can change. So if you want the node to resend the last message every 10 seconds, you set it to true and let's say 10. And if you have received a message in the last 10 seconds, then the device is considered as online. And if it's no message is received after 300 seconds, then so 5 minutes, then it's considered offline. So you can play around with these values. And by the way, if you select the node and you come to this one, then wait. Oh, the information one. I have written, oh bloody, come on. So I have written a documentation for that. So you can view the documentation here. So it talks about all the function it does, you know, what is the incoming payload, how it is expected to look like, and then the importance of the topic and some of the reserved topics that I talked about, and then how you use port 1, 2, and 3, and what is the status, or sorry, what are the details of the message that comes out of the third port. So these are the messages. So I knew that you can do, I mean, even from the past, I was aware that you can do documentation, because if you go to a function node, you can come here and you can do the documentation, but so far I was only using this to do comments, but now I realize that I can use the same sort of formatting that you would use in GitHub. So, you know, 1/ is header 1, 2/ is header 2, and these, I think this special apostrophe is for code, beginning and end of code section. So fairly useful. So you can look at the documentation if you get stuck as well. But going back to the example flow, so those are the values that you can modify on the function node. And then you replace debug 3 with a flex getter. You replace debug 4 with a flex write. And then out of the flex getter, you have to specify your own switch node. So you can switch the responses based on topic. And here I use the 5-second delay just for the testing purposes. So you can remove this, and then you can connect the advanced queue at the end of the flex getter and the flex write. So just like here. So this one goes to the advanced queue, and this one goes to the advanced queue node, which then goes all the way back to the Modbus queue. And with that, you will implement the same functionality as I just described here. I think I'm not going to save this. And of course, as I said, in here, the code is not the latest version, but anyway, I will update this. So by the time this gets uploaded, I will just copy and paste the latest version to the Modbus function. And as I said, the link to all this is going to be in the video description. So if you think that this is something that you want to use, then of course just download and make the changes that I described. Or if you think that your example is, or your use of a Modbus client is somewhat easier, then you can just use my example here, where you just have a simple, flex getter, and then you just send the request in. And of course here, in this particular case, I only used a single request or single type of request. But if you have if you are, querying different ranges or coils and registers as well, you can use the same approach even without my function node, and then just use a different topic. And then at the end of it, you can just use again the switch node to, direct the messages based on the topic and, how you want to process them. But again, if you are using this simpler method, this is not going to have the resend logic. So then you are relying on the, the internal code and the internal, queuing mechanism of the, the Modbus flex getter to, make sure that the messages are getting sent through. But again, if you're not using my function node, then your inject nodes, if they are set up to send a request every 2 or 10 seconds, they would just keep hitting the flex getter anyway. And I think it does an internal queuing as well, so it would just keep piling up all the messages. But as I said in the beginning, I don't see a point keeping or piling up all the get requests, because it's going to be the same request. So it doesn't matter if you are going to request the reading the coils or the registers once or 100 times, because the response is going to be the same. So this is why I said there's no point keeping a history, only just keep the last request for every single type. I hope it all made sense for you, and I also hope that you find this video useful. But that will be all for today. Thanks for watching, and hopefully see you in the next video.